the students, those who missed the first day. Okay, this class is for the students, those who missed the first day of our class. So I'll be reteaching the things that I have already taught you in the first day. Okay, let's start. So this is from the beginning of our class. Okay, so we are in our 2028 A level English medium physics class. So my first topic was to introduce you the subject physics. So we wrote the first topic as physics. Shall we write it? First topic, physics. Okay. So this is our first topic, physics. It was my first topic. Okay. Physics. Now, in our first topic, physics. So, what is the meaning of physics? So, what do you understand when we say physics? What's the introduction for physics? Okay. So, shall I say it like this? Physics is the understanding of the nature. Physics is the understanding of the nature by man-made models. Physics is the understanding of the nature by man-made models and structures. Okay. Shall we write it? After we write it, I'll explain it to you. First we'll write it, then I can explain it clearly. Okay. Shall we write it? Physics is the, take a CR book. Here you need 3 CR books. Up to now, as we are in the initial days, a single CR book is enough. Better to take a 120-page CR book. Okay, let's start. So we are introducing physics. We'll write this introduction sentence first, then I'll explain it to you. Okay, physics. Physics is the understanding of the nature. Physics is the understanding of the nature. Physics is the understanding of the nature by man-made models. Physics is the understanding of the nature by man-made models. Man-made models. Okay. Now, at the beginning, I explained what physics is. So, physics is the understanding of the nature by man-made models. We have to explain it more. We can just say physics is the understanding of the nature by man-made models, but what is it stands for? How to explain it more clearly? Okay, first I'll take an example. We'll write more things after this example. Okay, this was the same example I took in the class. Now say, here's our sun. Around our sun, Earth is rotating. Around our sun, Earth is rotating. So this is nature. In our nature, around our sun, Earth rotates. Now can you remember how we explain it? In physics, you may have heard, in physics, this natural phenomenon, orbital motion of Earth around sun, is explained by gravitation. Gravitation. So that's what I told you. So this is the nature. In nature, the Earth orbits around sun. To explain this, we have a man-made model called gravitation. In gravitation, they say there's a gravitational force acting on Earth towards sun, and there's a tangential velocity that Earth orbits, and there's a rotational velocity, angular velocity. I don't need you to understand all these things. I'm just giving you an example. Physics is understanding the nature through the man-made models. So this man-made model is called the gravitational. Through gravitational theories, we can explain how Earth rotates around sun. Okay, so the nature. So the nature here. So the nature. Earth rotates around sun. Earth rotates around sun. It's the nature. Okay. So what is the man-made model? Man-made model to explain this thing. Gravitation. This is physics. Explaining the nature through man-made models. When you are explaining this phenomenon through gravitational, what you get? Gravitational force is there. So can you see? There are some words that you use. Force, then the velocity of Earth, velocity. There are many more words that we use to do physics, to explain things using man-made models. Okay. Now I need this. We first wrote the topic as physics, then we wrote a sentence. Physics is explaining the nature through understanding the nature through man-made models. Now write example 1. Example 1. Okay. Example 1. Okay, write a small sentence. Natural phenomenon of Earth's rotation around sun. Natural phenomenon of Earth's rotation around sun. Natural phenomenon of Earth's rotation around sun. Natural phenomenon of Earth's rotation around sun is explained and understood through the man-made model called gravitation. It's a physics model. Which was initially developed by Newton. Okay. Okay, draw a small diagram there. No need to write these things. We already wrote them. Draw a small diagram. So in nature, Earth rotates around sun and it's a natural phenomenon. To explain it, man has developed a model to understand the nature. To explain it, the model is gravitation and it was developed by the famous physicist Newton. So this is physics. We are doing physics. And I will tell you why I am telling you this. I will, these are for the future use. Here, take a different color pen and write down the words that you can hear when you are explaining this phenomenon. When you are explaining this phenomenon using gravitation, what are the words that you can hear? Just write them from a different, within brackets, just write them from a different color. Force. I'm not going to teach you gravitation now. I'm not going to teach you this orbital motion. I'm coming to a certain point, what physics is and how it manages the things. To show that, I need some examples. Huh? Okay. Now, write down the words that you hear when you are doing gravitation. Force. You don't need to do gravitation. The things that you have already heard just here and there. Gravitational force. And when Earth moves, there's a velocity. And Earth is a very large mass. You have heard the word mass. Mass. Okay. Sun is also a larger mass. It's having a very higher mass than Earth. So this mass word, you have heard it. Just write the words that you have heard when you are explaining the things using physics. Force, velocity, mass, likewise. Huh? Okay. Now, okay. Okay. Now we will come to example number 2. We will come to example number 2. Okay. Now, this is my second example to introduce you what physics is. Example number 2. Okay. Now, one person is talking. One person is talking. When this person is talking, other people can hear him. Other people can hear him. So this is a natural thing. When one person talks, others can hear him. So this is a natural thing. To explain this natural phenomenon, to understand the nature, to explain this natural phenomenon, when one person talks, other people can hear. What is the man-made model? What is the man-made model to understand this natural phenomenon? It's the sound waves. It's the sound waves. We say when someone talks, there's a sound wave created. And this sound wave goes to the other person's ears. Then he can hear. So, physics is explaining the nature through man-made models. So, what is the nature? Sound. Nature is when someone talks, other people can hear. So, it's the nature. How to explain it through a man-made model? Sound waves. So, physics is the part called sound waves there. Okay. Okay. Write example 2. When someone talks, we'll just write. Okay, example number 2. When someone talks, others can hear. When someone talk, others can hear. When someone talk, others can hear. This natural phenomenon is explained through the man-made model called sound waves. It's physics. Through the man-made model called sound waves. It's physics. Okay. So this is a sound wave. So physics is explaining the nature through man-made models. Okay. When someone talks, others can hear. It's the nature. How to explain it? Through the model called sound waves. Okay, just draw the diagram. And to use in the future, can you write the words that you can hear? Draw this small diagram. And can you say me, what are the words that you hear? What are the words that you hear when you go to this model? When you go to this sound waves model, what are the words that you can hear? Wavelength. I'm not going to explain you wavelength now. I just want to remember you the words that you hear. Wavelength. Then the velocity. Sometimes you may use this word distance when I talk. People from a far distance can hear. So the distance word used. Time that takes the sound to travel to the other person. Time. These kind of words are often used when you are explaining the nature through physics, through man-made models. Okay. Okay, wavelength, velocity, distance, time, these are the things. Okay. So it's clear now. Physics is the model, physics is the explaining the nature through man-made models. Sometimes this model might be the theory called gravitation. It explains the Earth's orbital motion around Sun. Sometimes this model can be sound waves. It's explain the nature how one can hear when when another one talks. Okay. No need to draw a diagram. Shall I say another thing? Shall I give you another example? No need to draw a diagram. Shall I give you another example? Now, take this natural phenomenon called lightning. Take this natural phenomenon called lightning. When lightning happens, it's nature. How to explain this natural phenomenon through a man-made model? Have you heard electric charges? We say the lightning, the way the lightning happens is explained through the theory of these electric charges. So the man-made model to explain this natural phenomenon lightning is the electric charges and how this they flow, electric charge flow. Electric charge flow through the air. Electric charge flow through the air. So, so the natural phenomenon is lightning. To explain the model is electric charge flow through the air. And there, when we are explaining these things using these models, we always hear these words. There's another word, electric charge, electric charge. Okay, likewise, we can hear a large number of words. Using these words, man has built models to explain the nature. It is physics. Okay, so this is physics and how it starts. Okay, then next thing we discussed in our first class is about these words. Now I was coming to this point little by little. Now, when we come to explain the things, explain the nature using man-made models, we always get these words: mass, time, force, velocity, acceleration, okay, length. And what are these words? What are these words? What are these words? When we goes to explain the things, natural things using physics models, we always get these words: time, mass, force, acceleration, distance, velocity. So what are these words? These words are called physical quantities. These words are called physical quantities. A physical quantity is a property in the nature that we use to explain nature using physics, in physics models. So these special words that we always hear are the properties of nature: wavelength, a distance, then the mass, amount of matter, force, the push or pull, force, the push or pull, it's a property of the nature. The mass, the matter, amount of matter, it's a property of the nature. Velocity, how the things move, whether fast or slow, it's a property of the nature. So these words that we hear are known as physical quantities. Okay, now write a small star mark. When we are inside these physics models, 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 the words we hear, the words we hear, the words we hear, the words we hear are known as physical quantities, are known as physical quantities. Words we hear are known as physical quantities. Are known as physical quantities. Physical quantities. Physical quantities are the properties of nature. 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 Physical quantities are the properties of nature used to explain the relevant conditions. Used to explain the relevant conditions. Used to explain the relevant conditions. Physical quantities are the properties of nature that are used to explain the relevant conditions. Okay. In physics, physical quantities should have, in physics, physical quantities should have, in physics, physical quantities should have, in physics, physical quantities should have numerical value. Physical quantities should have numerical value to explain their magnitude, a numerical value to explain their magnitude, and a unit to explain, and a unit to explain how it is measured, and a unit to explain how it is measured, and a unit to explain how it is measured, and a unit to explain how it is measured. Okay. Here, when you say a physical quantity, it's a property in the nature. When you say a physical quantity, it's a property in the nature to explain the relevant condition. Say a force, it's a push or a pull. And say a force, it's a push or a pull. It's a property in the nature. And how the force is measured? 10 newtons. 10, a numerical value to explain the magnitude. Magnitude, the size of the force is 10, and you need a unit, newtons, how it's measured. Okay, let's come to another situation. Now a vehicle is moving. Now a vehicle is moving. The velocity of the vehicle, 10 meters per second. So it's a property in the nature, how fast it moves. Okay, to explain this, you have to explain the physical quantity velocity, you have a magnitude, a numerical value 10 to explain the magnitude, and unit to explain how it is measured, meters per second. Okay, just write these two things. So these are the physical quantities. Force. These are the physical quantities. Force and the velocity. Properties of nature. Properties of nature. Okay. To explain these physical quantities, the properties of nature in the relevant situation, to explain these physical quantities, these properties of nature, how we explain it? A force, a push or pull, it's a physical property. It is explained by a 10 Newton force. The force is 10 Newtons. It has a magnitude, numerical value 10, and a unit, Newtons. Velocity. The vehicle is moving at a velocity of 10 meters per second. The magnitude 10 and the unit, meters per second. Okay, just draw the diagram. Okay. So, from the things we learned up to now, from the things we learned up to now, what is the conclusion? What is the conclusion that we can get from the things we learned up to now? What is the conclusion that we can get? Physics is the understanding of the nature through the man-made models. Physics is the understanding of the nature through the man-made models. When we are understanding the nature through man-made models using physics, we get to explain. We get to explain about the properties in the nature. We have to explain the properties in the nature. These properties in the nature are called physical quantities. To become a physical quantity, it should have a magnitude explained from a numerical value and a unit. For a property in the nature to become a physical quantity, it should have a magnitude and a unit to explain it. 10 Newton, the physical property is the push. So the physical quantity is known as force and it's measured by Newton. Okay. So this is the situation. Now, in our syllabus, our first unit is to understand about these physical quantities and their units. Okay, physics is understanding the nature through man-made models. When we are doing this, we get several properties of the nature that we have to use. These properties are called physical quantities. They have units to measure them. Okay, so our first lesson in our syllabus is to understand this what are the physical quantities we meet and what are the units we use to measure them. Okay, now write unit 1. Now write unit 1. Okay, so this was a general explanation how the things were. Okay, now write unit 1. Now write unit 1. Okay, unit 1. Okay, then write the topic of the unit 1. Physical quantities and units. Physical quantities and units. It's our first unit. Physical quantities and units. Okay, physical quantities and units. Now, okay. When we are coming to our first topic, physical quantities and units, you know why the first lesson is placed it as the first lesson. Why? When we are doing physics, we get these models. Inside all these models that we are going to do in the future, light, mechanics, waves, they are the models man created. In all these models, we hear these words, physical quantities. So it's better to pay our attention to them first. So what are the physical quantities we meet and their units is the first lesson. Okay. Now, when in my explanations, I have told you this thing earlier. What? Generally, I say this to all the children, and in all the cases, I say this. Our A level syllabus, physics syllabus, starts from the beginning of the subject. It doesn't start from the end of the O levels. Inside your O level science, there are some physics parts. Some children think our A level physics parts starts from the points that we have ended the O level physics inside O level science. No, O level physics starts from the beginning. A level physics starts from the beginning. So it's a great chance for you to start from the beginning. Okay. Now when I come to physical quantities and units, I'll start it from the beginning. That's how the syllabus goes. So the first thing is for you to understand how these physical quantities and units came to the present day, how this lesson was developed up to the present day from the beginning of the civilization. So it's that much good. The syllabus starts from the beginning. Okay. Now just listen to me. So what were the oldest physical quantities man understood? Physical quantities are the properties in the nature. What were the oldest physical quantities man get the idea, man understood? Mass, length and time. Amount of matter, mass, length, the gap between 2 points, and time. Time means something is flowing. We are getting older. Time passes, that concept. Okay, this mass, length and the time were the oldest physical quantities man paid the attention. Okay, so the physical quantities and units is the first unit, our first topic. There, physical quantities are the properties of nature, and we have to pay our attention to the units that we measure them to inside this lesson. Okay, and the syllabus starts from the beginning. Of the civilization, how this lesson came up to the present. Okay, so under this unit 1 topic, write Roman number 1. Mass, length, time. Mass, length, time were the oldest physical quantities. Mass, length and time were the oldest physical quantities, mass, length and time were the oldest physical quantities man paid his attention. Man paid his attention. Okay, man paid his attention. And children, can you tell me what are the oldest units? That man used to measure these physical quantities, especially the length? What are the oldest physical quantities man used to measure these? What are the oldest units man used to measure these oldest physical quantities that he paid the attention? Length, the gap between 2 points. What are the oldest units? Is it meters? Nowadays, we use meters to measure length. In those days, man was in the jungle and on those days, did he use meters to measure length? The physical property, the gap between 2 points, is the physical quantity length. To measure a physical quantity, there should be a unit. So what were the oldest units that were used to measure the length? Have you heard something called handspan? Handspan. Handspan. Handspan is this distance. Handspan is this distance from the span of your hand. 1, 2, 3, 4, 5 fingers. Handspan. This is your hand. This one. Handspan. Cubit. Have you heard something? Cubit. When you take your hand like this, cubit. When you take your hand like this is the cubit. Cubit. Then this is handspan. Shall we just draw them? I don't need you to draw the clearest pictures that you have ever drawn. Just note them down. Handspan. Cubit. And there's another very old unit, shouting distance. It's a very old one. Shouting distance. The distance that's heard when someone is shouting. Shouting distance. Shouting distance. Handspan, cubit, shouting distance. Okay. Okay. So these were the oldest units. To measure the length. Oldest units to measure the length. Handspan, this thing. Cubit, this thing. Shouting distance, the distance that can be heard, the distance when someone shouts, what is the distance, then other people can hear him. Shouting distance. Okay. And can you tell me the oldest units? Can you tell me the oldest units to measure the mass? How the mass was measured in the old days? How the mass was measured in the old days? How the mass was measured in the old days? Now, especially when the agriculture was popular in all this agricultural era, how this mass was measured? Actually, to measure the baskets of grain, to measure the grain, which was the method? Certain stones were used. Say there's a stone, stone with a certain mass. Okay, you are taking some potatoes to the market, and from that stone, the potato bundle you bring is 2 times the mass of that stone. Okay, now you are taking some. Let's say you are taking a big pumpkin to the market to sell, and how the mass is measured? There's a stone, certain stone. This pumpkin is 3 times that of the stone in your village. Certain stones are used to take idea about the mass. You are taking a jackfruit, a large one. It's 5 times the mass of that stone. Likewise, or in oldest days, to measure the mass, certain stones were used. Just write it here. certain stones with the certain stones with a certain mass, certain stones with a certain mass. Okay, these were the oldest method to measure the mass, and handspan, cubit, shouting distance were the oldest method to measure the length. And what were the oldest method to measure the time? What were the oldest oldest methods to measure the time? Give me a small time just to drink some water. I'll drink some water and I'll come quickly. Meantime, tell me what are the oldest methods to measure the time? What are the oldest methods to measure the time? Have you heard something called sundial? Have you heard something called sundial? Pathatiya in Sinhala, sundial. Okay, you have the phone in. If you have the phone in your hand, give a Google search. Sundial. What is sundial? There's a plate. Inside this plate, in this plate, there's a something. There's something like this. When sun emerges, due to the sunlight, there's a shadow created. And when sun moves, this shadow changes. Sundials are used on those days. Sundial. In a certain plate, there's a small rod set up vertically or with a inclination. And when sun rises, what happens? This small rod develops a image, develops a shadow, and this shadow changes when the sun moves with time. So that was used to take idea about the time, sundial. Now, Puta, you don't need to study these things for the exam. Just remember these things as facts. Okay. So this is what I'm saying. In old days, length, the gap between 2 points, a physical property, a physical quantity, then the mass, amount of matter, and the time were the oldest physical quantities. People got the idea. People thought of getting an idea that they examined. Okay, cubit, handspan, shouting distance, or whatever the stones used to measure mass, and sundials. Likewise, there were many old units to measure them, to measure these physical quantities. Are they good units? That's what I want to tell you. Are they good units? No, they are not good units. Why? Let's say the sundial. If it is a rainy day with clouds, can you use sundial? No. If it is a rainy day with clouds, can you use sundial? No, you can't. Okay. Then it's not a good equipment. It's not a good method. It's not a good unit kind of a thing. Okay. Now say shouting distance. When someone shouts, the shout is heard to a certain distance. If a person with a higher energy shouts, or the same person, if he shouts with a different energy factor, what will happen? His sound will move further and it can be heard for comparatively a larger distance. Okay. So these things are changed. So they are not fixed units. They are not good or they are not accurate units. Let's say a stone. Is it an accurate unit? There can be many mistakes that can happen when you try to measure the mass through a stone. What about this handspan? These are called body-based units. Handspan, cubit, they are based on body. What happened? When the person grows elder, when he grows, what happened? The handspan change, cubit change. So that's what I need to point out. These older units are not good units. They are not accurate. Okay, they change with time, with the person and the method how they used. and with the location. Say in a colder day, shouting distance, it cannot be heard for, so the distance the sound travels minimizes with the temperature of the area. So it changes with the location. In a cold area, the shouting distance for a certain man is different from when the same man shouts in a hot area in a hot day. The distance that sound travels, it changes the location. Okay, so these are the things. So let's write a single sentence telling that these are not accurate units. Okay, write a small sentence. These old units are not accurate. 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 They change with person. They change with person. Location. They change with person, location, comma, with time. They change with person, location, and with time. These are not accurate. They change with person, location, and with time. Okay? So these are not accurate units. And there's another thing. You can't reproduce these units. Say, when you are getting older, your hand span change. And can you reproduce your hand span which you had when you are in 5 years of age? Now you are 16 years. Now you have a certain hand span. Can you reproduce the hand span, the gap of this gap which you had when you are 5 years of age? No, you can't reproduce it. Okay, you shout. When you shout, the distance, when you shout, you get the shouting distance. The distance traveled by the sound, that the distance that you can be heard from the other people, shouting distance. And can you create the same shouting distance again in a different day? You will shout again, but the sound will not travel the exact distance that it traveled last time. It will be not heard up to the exact point that it was heard last time. Okay, so these things cannot be reproduced too. Okay, complete the sentence. Now we said these are not accurate. They change with time, person, and the location. Right, add a small sentence to the same paragraph. These old units are not reproducible. These older units are not reproducible too. 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 Okay. Now Puta, so this is the situation. We are in our first lesson, physical quantities and units. This is the first lesson and it's a very important lesson too. Why? It gives us the idea about how this physics subject flows. Why? Inside physics subject, to explain the physics, explain the nature, we have these models, physics models. In these physics models, these properties of the nature are known as physical quantities and they are often used. So these physical quantities have units and it explains the way how they are measured with the numerical value as the magnitude, and there's a unit, a 10 Newton force, 10 meters per second velocity. Okay. Now we have these newtons, meters per second, meters, seconds, but older days we have a very basic kind of units to measure the physical quantities. Actually, the physical quantities are the mass, length, and the time are the oldest physical quantities we set our attention. And they are this handspan, cubit, shouting, distance, sundial, the thing to measure the time, stones to measure mass. They were not accurate things. That's what I told. They are not reproducible. Then they changed the time. So these things were rejected. These things were rejected. And in 1824, in 1824, in 1824, British units came. In 1824, British units came. In British units, length was measured by feet, then yards, miles. Okay, then the mass was measured by pounds, and the time, let's say minutes. Why I am saying minutes? Why I told you let's say minutes. In original British measuring system, there's no any specified unit to measure time. But those days, minutes were popular. So the British system also, people used minutes. But if you Google search and if you do a AI search, asking whether there are exactly a unit to measure the time that was exactly given in British system as its own, no, there's nothing. But the minutes, hours were the things that they were using on those days too. I'm talking about 1824. Okay, so we can consider it as minutes. Okay, just write write a small sentence. As this, then we in our paragraph we wrote that these older units are incorrect, that they are not accurate. Okay, then write so new unit systems were introduced. So new unit systems were introduced. So new unit systems were introduced. Now we have already written that these older unit systems are not accurate and the reasons. Okay, then continue the sentence. So these older units were rejected. So these older units were rejected and new unit systems were introduced. So these older units were rejected. So these older units were rejected and new unit sets were introduced. New unit sets were introduced. Okay. Now come to Roman number 2. Then you can write this thing. In 1824, British units. Length is measured by feet, yards, miles. Mass is from pounds. Time is from minutes. And again, you can write it with me. In 1874, there's a unit system introduced called CGS units. Actually, this was developed mainly in UK and this was developed mainly in France. This was developed mainly in France. Okay, CGS. In this CGS unit system, to measure length. Okay, write it with me. Write it with me. To measure length, centimeters. Centimeters. C stands for centimeters. To measure mass, grams. G stands for grams. To measure time, CGS. seconds were used. Okay, just write them. Okay, in 18, now as these older unit methods were inaccurate, new systems were introduced. New systems were introduced. And in these new systems, one of the main new system that was introduced on those days to reject the older ones was the British unit system developed in UK to measure length, feet, yards, miles, mass, pounds, time, minutes. In 1874, CGS unit system, especially in France. Centimeters to measure length, grams to measure mass, time to measure seconds. Children, are these unit systems bad? No. These are very good unit systems. These are very good unit systems. Why? Still, we measure the time from seconds. So this is not a bad unit system. Still, even the SI unit is kilograms. We have the grams in use, grams. It's not a bad one. Still, we use miles. We use miles, feet, no problem. So then, why these things were rejected? We know now we are in SI unit system, not in these British units and not in the CGS units. We use SI units. So, what might be the reason for the SI units to be introduced instead of these British and CGS units? They are not bad. If they are bad, why we are using time, using seconds to measure time? In nowadays also we are using seconds, so it's not a bad one. So what's the case here? This is the case. When people use separate unit sets in separate parts of the world, when people use separate unit sets in separate parts of the world, what happened? It's very contradicting. It's very difficult to carry out the businesses. It's very difficult. It's very annoying to carry out the educational educational knowledge sharings. Why? When someone from UK send a letter to a person in France, and this scientist who write the letter use the British units, but the scientist in the France, he can't understand this, the things that his friend sent to him. Why? It's from a different unit system. He is used to CGS unit system. Okay, so the businesses, the knowledge sharing, all these things goes to a trouble when the separate parts of the world use separate units. So in 1960s, scientists came to a conclusion to use a single unit set, to use a single method of units around the world. Standard International SI units were introduced. So this is the next development. Even though these are good things, it's difficult to maintain separate unit usages in separate parts. So in 1960s, it was bought under a single flag, SI unit flag, SI units. Now they are worldwide accepted. Okay. Write Roman number 3. Write Roman number 3. Even the British and CGS units are good ones. Even the British and CGS units are good ones. Even the British and CGS units are good ones. Even the British and CGS units are good ones. Even the British and CGS units are good ones. It's difficult in business. It's difficult in business. It's difficult in business, comma, knowledge sharing. Knowledge sharing. It's difficult in business, comma, knowledge sharing, comma, education. To use separate unit systems. To use separate unit systems in separate parts of the world. In separate parts of the world. In separate parts of the world. So a single common unit system. So a single common unit system. So a single common unit system called, so a single common unit system called SI units. So a single common unit system called SI units. SI units. Within brackets, Standard International. Within brackets, Standard International. So a single unit system called SI units. Within brackets, Standard International. Standard International was introduced. Was introduced. Was introduced. Okay. So our next consideration is about the SI unit system, Standard International SI unit system. Okay. We haven't done much. We have done things up to another 15 minutes time. We have done the things up to another 15 minutes time. From another 15 minutes, I'll complete the first day. Then you can join with the second day. I'll explain these things later. Let's finish the lesson. Okay, we have another 15 minutes left. Okay, let's continue. Okay, then write SI units. Then write SI units. SI units. SI units. Okay. SI units. Now, is it clear up to the point that how we came to this point? Physics is the explaining of the nature using the man-made models. When we go to explain physics, when we go to explain nature using man-made models, words are often heard. Velocity, force, mass, time. These are physical quantities. These physical quantities are the properties of nature which are having a numerical value for the magnitude and a unit to measure. Okay. Now, the oldest physical quantities that man paid attention was mass, length, and time. They had older units too. But as these units were not accurate, new unit systems were born in separate parts of the world. But it's difficult to maintain separate unit systems in separate parts. So in 1960, it was brought to a single flag SI unit system to measure the physical quantities. Okay, now we are learning about SI unit system. As this SI unit system is a very advanced one, inside this SI unit system, there are many categories. Okay, the first category is base physical quantities and base units. Okay, under this SI units, write number 1, base physical quantities and base units. 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 Okay. Now, in SI unit system, I told that it's a very advanced one and it's common for the complete world. It's an international standard one accepted by all the places in the world. And as it's a very sophisticated one, there are many subcategories. First subcategory is the base physical quantities and base units. Okay. Now there are 7 base physical quantities and base units introduced. There are 7 base physical quantities and base units introduced. There are 7 base physical quantities and base units introduced. Let's write them. First is length. First is length. SI unit to measure the length. SI unit to measure the length. First is length. Okay. SI unit to measure the length is meters. And let's write it with me. And symbol is simple M. And the symbol is simple M. Length is measured by meters. Symbol is simple M. Then mass. Kilograms. Kg. Symbol Kg. So what's the place that I am teaching you now? Now we have come to this SI unit system. The CGS and British unit systems were refused, not because they are bad, but it's difficult to use 2-3 unit system inside the world from place to place. So SI units are introduced. It's a common and a very sophisticated unit system. Now, as it's a common and a very sophisticated one, there are many subcategories that these SI units are divided. The first subcategory is base physical quantities and base units. Now I am introducing them to you. So these are the base physical quantities. These are the base physical quantities. Length measured by meters in SI unit system, symbol simple M. Mass measured by kilograms in SI unit system, symbol kg. Time measured by seconds in SI unit system, time is, the symbol is simple S. Thermodynamic temperature. Thermodynamic temperature. Thermodynamic temperature. Thermodynamic temperature is measured by kelvins. Name of a scientist. So it's a capital. Kelvin, capital K is the symbol. Kelvin, capital K is the symbol. Okay. Then electric current. Electric current measured by amperes. It's the name of a scientist. So it's capital A. Then there's a physical quantity called luminous intensity. Luminous intensity. It's measured by candela. I will explain. Candela, simple C, simple D. Simple C, simple D. Then there's another physical quantity. It's also base quantity. Let's explain them. It's amount of substance. Amount of substance. Measured by mole, symbol MOL. measured by moles, MOLE, and symbol MOL, symbol MOL, symbol MOL. Okay. Okay. Have you finished? So this is the situation, children. This is the situation. In our newly brought topic, it's about the latest unit system that we use to measure the physical quantities, our SI unit system. Inside this SI unit system, as it's a very sophisticated one, there are many subcategories. First category is the base physical quantities, base physical quantities and their units, base physical quantities and their base units: length, mass, time, thermodynamic temperature, electric current, luminous intensity, amount of substance. They are the 7, 1, 2, 3, 4, 5, 6, 7. 7 base physical quantities. 7 base physical quantities. Putha, what? Now length, the gap between 2 points. The mass, amount of matter. Time, the thing that passes, making us older day by day. And the thermodynamic temperature, the hotness, thermodynamic temperature, hot or coldness, you know that. Electric current, you have an idea. In future lessons, we'll explain them more and more. I'm just introducing electric current. What is luminous intensity? Have a rough idea. We'll explain them in the correct lesson. Luminous intensity means just have idea, the brightness. When you lit a single candle, there's a small brightness. When you lit 2 candles, there's more light in the room. Okay, brightness is higher. That's the luminous intensity. The brightness that you feel through light, luminous intensity, luminous intensity. The brightness that you feel through light. Okay, we have lessons to explain them, so no need to worry. And amount of substance. This amount of substance is also a different kind of a physical quantity. I think it's better to explain when they are in the correct order. That means when we are in the exact lesson. Okay, so these are the 7 base physical quantities. Can you say me why these are known as base quantities? Can you say me why these are known as base quantities? Now, force, it's also a very popular physical quantity. It's always used. Velocity, it's also a very popular physical quantity. It's always used. So why not this force and velocity kind of physical quantities are here? Even the luminous intensity is there, but the force is not there. So definitely the method that we have selected these base quantities is not according to their popularity. If we select the base quantities according to their popularity, definitely force should be inside. It's a very popular physical quantity. No, this is not chosen from the popularity, considering the popularity. These base physical quantities are special. These base physical quantities are the physical quantities that are independent from one another. That are independent from one another. Putha, say force from your O levels. Force is the mass into acceleration. Force is the mass into acceleration. So inside force, you have mass and acceleration. Inside acceleration, you have velocity over time. So time factor is also there. So even the force is a popular physical quantity, there are many base quantities inside force. Take velocity. Velocity is the displacement over time. So inside velocity, the displacement, length factor is there. You have to divide it by time, so time factor is there. So velocity is a contribution of length and time. When you divide velocity again by time, you get the acceleration. So acceleration is also a combination of displacement, the length divided by time, again time. That means it's also a combination of length and time. So force becomes a combination of mass, length, and time, because force is equal to mass into acceleration. Acceleration contributes from length and time when it comes from velocity. So even some popular physical quantities are there, force, velocity kind of things. They are contributions. Inside them, there are many factors opening from these base physical quantities. So they are not selected as base physical quantities. Base physical quantities are the physical quantities which doesn't depend one on other. Which doesn't depend one on other. They are separate. Okay, so these are the base physical quantities. Okay, these were the things we did. But wait, shall we write the final sentence? Shall we write the final sentence? Okay, write down. Base physical quantities, base physical quantities, base physical quantities, base physical quantities are, base physical quantities are independent from one another. 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 All the other physical quantities, all the other physical quantities has the effect from these base quantities, has the effect from these base quantities. Okay, we'll explain that in next week, how these base quantities affect the other physical quantities. They are known as derived physical quantities. It will be our second day topic. Okay, so in SI unit system there are base quantities. There are 7 base quantities: mass, length, time, electric current, thermodynamic temperature, amount of substance, then luminous intensity. These are the things. And these 7 base physical quantities are independent from one another. To explain time, you don't need mass. To explain thermodynamic temperature, you don't need to consider about the time. Okay, to explain the luminous intensity, the brightness of light, you don't need to consider mass. They are independent. But when you go to force, when you go to velocity, they are dependent. Velocity depends on length and time. So velocity is defined using length and time. So inside velocity, you have 2 base quantities contributed, length and time. But for the thermodynamic temperature, nothing contributed. You don't need to use mass to explain thermodynamic temperature. It's an independent one. Likewise, the 7 physical quantities that are independent from one another are the base physical quantities, and the others are known as derived physical quantities. It's our second day topic. We haven't come to that point yet. Okay, and so these are the SI units to measure the base physical quantities: length by meters, symbol M; mass by kilograms, simple kg; time by seconds, simple S; thermodynamic temperature by Kelvin, capital K; electric current by ampere, capital A; luminous intensity by candela, simple C, simple D, candela. Okay, we'll come to explain these things when we are at the exact lesson, but just have the idea. There's something called amount of substance, mole, measured by MOL. It's also a base physical quantity that can be explained future when we are exactly in the lesson. Okay, so these are the first things that we have done in our first day. Okay, so if you wish to join the class, Puta, you have to keep a WhatsApp message under the unit that under the link that we have sent you in the WhatsApp thread that you have opened with us. You have to keep us a WhatsApp message informing that you are willing to join our class. Our next class is on this Sunday. What's the date? 15th. Okay, the next class is on 15th, Sunday at 7:30 p.m. at 7:30 p.m. So before that, you have to send us a message. Okay, Puta. Then good night. Have a good future. Okay, goodbye.